Hello all. So this is second part of this video on frequency and graphs. So here we'll look at the graphs, bar graphs, pie charts, bar graphs and histograms, line graph and distortion in graphs. So the graph is a visual display used to understand the frequency of value categories or values of variables. Graphs also allows a reader to obtain comprehensive picture of the distribution of values without having to focus on unnecessary details. So uh, it looks like this. There are vertical lines and horizontal lines. Vertical lines, we call them y-axis, and they are ordinates. And horizontal lines are x-axis, also called abscissa. The points at which the x-axis and y-axis meets is called point of origin. The bar graphs for nominal variables. This is one of the example where the enrollment for each introductory courses in chemistry, physics, economics, political science, psychology is listed here. And this is like bar graph or bar chart. From here you can see like how the data will look like for this graph, which course has the most students enrolled in it. So maybe the economics, you can see here the order the courses by. If you want to order the courses by enrollment from the lowest to highest, so you can, looking at the graph, you can do that. The enrollment in economics is approximately how many times bigger than the enrollment in chemistry. So you can answer that question looking at the graph. Approximately how many students were enrolled in the course with the most students. Approximately how many more students in economics than physics. So there are a number of questions you can address looking at these such graphs. So there is another way of presenting data. This is like pie chart, which looks like a circle, and it looks like a pizza. So there are different shapes and sizes. Here the family weekly expenditure on its house, mortgage, food and fuel are listed below. So there are $300 for mortgage expenses, food 225, fuel $75, so total $600. And in the third column we have listed how much percent of this total for each expenses. And accordingly, in this pie chart you can see the 50% goes to mortgage, 12.5% goes to fuel, 37.5 goes to food. So this is like visibly very clear when we have data from survey or other sources, how we can project them when we write our reports. This is another pie chart. I got it from online. So the wildfire caused during 2013 till 2017 in California. So what were the causes? So you can see the different percentage of particular causes listed here according to this data. So the bar graph and histograms, we'll look into histogram, how it looks like. But essentially they are different and unique. So the bar graph are visual representation of comparing values. However, the kind of bar graphs that display a more specific way of presenting comparison, that is histogram. The bar graph is often used to show a visual comparison of discrete elements, and while the histogram is used to show the frequency of non-discrete or continuous variables or items. In regard to bar graph, the elements or items are taken as a separate entity. However, the items in the histogram are usually the numbers that are grouped or categorized in such a way that they are considered to be ranges. Normally, bar graph is drawn or depicted in such a way that a bar representing the frequency of an item is not touching the bar of next item, so they are independent. There is visible space between the bars. The bar in the histogram are always touching the next one. There are no spaces in between. So we'll look how we can draw histogram using graph paper. So you can do this by your hand on the graph paper. So on the x-axis on the below, you can see the class interval. So from so the point, it is pointed to in the middle, and for each of them you can see how we have listed the numbers for each lines starting from 0 till 48, and vertical y-axis is frequency. So in this same graph, what we do is we point, we have like continuous or class intervals. First interval is 0 to 4, second interval is 5 to 9, then 10 to 14, 15 to 19, and so on. So this may be the age group, and you can see for age group of, they may be age group of the respondents. For each continuous class interval, we need a midpoint. So for 0 to 4, we have 2 midpoint. For 5 to 9, 7 midpoint, and so on. So what you do to calculate midpoint, you add both the interval, like 0 plus 4, that is 4, divided by 2, that is 2. 5, the second interval is 5 to 9, so 5 added to 9, that is 14, so divided by 2 is 7, so that is midpoint. So likewise you need to find the midpoint, and then then you connect these lines here based on the frequency for each of this class interval. So for 0 to 4, there may be one number of respondent. 5 to 9, there are 2 respondent. 10 to 14, there are 4 respondent. So likewise, you can prepare this histogram. And also there is frequency polygon, a continuous line that represents the frequency of scores within a class interval. So at each midpoints, you just connect that line, and then the line from midpoint of each dots, as you draw the line connecting those midpoints, it creates a polygon. And then this same midpoint, if you keep on connecting, but you use not the actual frequency but the cumulative frequency, you keep on adding one frequency with the another, and then you can see how this class interval look like. The another way of presenting data is line graph. It shows the difference in frequency or percentage among categories of interval ratios, and it points represent the points representing the frequency of each category, and they are placed above the midpoint of categories and are joined by a straight line. So in this example, you can see the population of Japan, age 65 and above, and that is in a horizontal line. You can see the intervals. On the vertical line, you can see the population, and the lines, those two lines you can see, and the population in 2014, the top line, and then 2010, the line below. So you can see how this for each age range, you can see how this particular line is used to depict the increase or decrease in the population in those 2 years. So as we have seen the frequency and graphs, it is also important to understand there is distortion in presenting these graphs and the presentation of data, and we need to be very mindful of those when we read newspaper or articles. The graphs cannot only quickly inform us, they can also quickly deceive us. We are more vulnerable to being swayed by distorted graphs because we are often interested in general impressions. So in this example of graphs, you can see the female representation in national parliament in 2015. So different countries, you can see how many percent of females in the parliament. So it looks like there is not much variation here across the countries, except Rwanda has little bit higher representation. However, when you look at the same information presented differently in this another bar graph, you can see there is drastic or significant low representation in many countries as compared to Rwanda and Bolivia. So it is many times up to the statistical or people who prepare these reports to represent what they want to show in their graph. So, but we need to be mindful of to understand what this particular data means. So in this first graph, you can see the percent of female start from 0 till 70. In the second one, it starts with 30 and onward, 30, 35, and the range is here is between 10, 20, 30, 40, 50. So 10 kind of interval. And then here it is like 35 to 40, like gap of 5. So here it is not start, very important to notice, it has not started with 0, and that makes a huge difference as we see the distortion in both of these images. So as we have seen in this two presentation, how we can use frequency tables, graphical presentations, and also bivariate presentation of data, and all this introductory or descriptive way of putting our data is extremely important to understand. And so this was like two-part presentation of the presentation on frequency and graphs. Thank you.